In our previous videos, we have discussed various types of numbers. We know what are rational and irrational numbers, and we can differentiate a rational from an irrational number. Also, we are familiar with the real numbers. That set of real number is the combination of rational and irrational number, and we assume the real number includes every number. But the question is, what about the numbers that gives a negative number after squaring? As we are familiar, the square of any real number can never be equal to -1. For example, square of 3 is equal to 9, square of 2 by 4 is equal to 4 by 16, square of -3 is equal to 9, means square of any real number can never be equal to -1. So what are these numbers? How we can define these numbers? To which set these numbers belong? So these are the questions we will answer in our today's lecture. And to answer that questions, we have to enhance our knowledge of numbers. So let's start with this. Basically, any number that gives a negative number after squaring is included in imaginary numbers. For example, we have an equation x squared is equal to -1. Now you can see there is no solution for this equation in the set of real numbers. So this number is called imaginary number. We can get this equation from this after taking square root on both sides of this equation to get rid of square on x. So we have x is equal to root -1. This is called imaginary number. We usually denote imaginary numbers with I. This I is called unit imaginary number. I is equal to root -1. We can also read this I as iota. Any number that involves I is an imaginary number. For example, 3i, 7 by 5i, 6 by 7i, root 2i. All are imaginary numbers. You should keep in mind, if we ignore I from these numbers, then all these numbers are real numbers. So this is the concept of imaginary number. Now the question is, what if we combine imaginary and real number? Is there any platform by which we can combine these numbers? So the answer is yes. We can combine these numbers in the set of complex numbers. So this is the equation of complex numbers. We can define complex numbers in a way: the numbers that can be written in the form of a plus ib, where both a and b are real numbers and I is equal to root -1, are called complex numbers. From this equation, we also define complex numbers in words: the combination of real numbers and imaginary numbers are called complex number. Yes, this is true. So this is the definition of complex numbers. Now let me tell you, complex numbers has two parts. One is real part and other is imaginary part. For example, let we have complex number in general form. Z is equal to a plus iota b. We usually denote complex number with this letter Z. We have this complex number a plus iota b. In this complex number, a is the real part and b is the imaginary part. Keep in mind, only b is the imaginary part. ib is not the imaginary part, only b is the imaginary part. We frequently write real and imaginary part like this: a is equal to real part of complex number z and b is equal to imaginary part of complex number z. For example, we have a complex number c that is equal to -3 plus 2 iota, or 2i. In this complex number, -3 is the real part and 2 is the imaginary part. You can note only 2 is the imaginary part, not 2i. So these are the two parts of complex numbers. Now the question is, how we can make possible that two complex numbers are equal? Is there any method to confirm either two complex numbers are equal or not? So the answer is yes, we can make this. Two complex numbers are equal only if the real parts of both complex numbers are equal and imaginary part of both complex numbers are equal. For example, we have two complex numbers z and w in general form. Z is equal to a plus iota b and w is equal to c plus id. Now these two complex numbers are equal only if the real part of z is equal to the real part of w and the imaginary part of z is equal to the imaginary part of w. Means a is equal to c and b is equal to d. So this is the method by which we can confirm either two complex numbers are equal or not.